Okay. All right. So the area of a sector is 30 pi square centimeters. All right, now, stop a minute. You got to draw your own picture. The area of a sector. So remember that a sector is a piece of pie. So we know that the area is 30 pi. We also know that the radius is 13. Our job is to find the central angle. Okay, how do we do this? Anthony?
Can we still do the whole sector?
The area of the sector formula? Absolutely. What's the formula say?
X over 360.
X over 360
times 169 pi.
times 169 pi has to equal 30 pi. That's exactly right. You know the formula. The formula says angle over 360 times the area of the circle, pi r squared, and they tell you this time it has to equal 30 pi. Agreed?
Yes.
Now, this is kind of messy. I'm going to multiply these two things together over here on this side. So that would give me 169 pi x over 360. Would everybody agree with that? Would everybody agree that I can multiply this together and I get 169 pi x over 360? Is that right?
Right.
Now, I know those fractions and ugly and letters and pies and everything else, but if you had 2x over 3 equals 8, wouldn't you multiply both sides by 3? So what are we going to multiply both sides by? 360. So 169 pi x equals, okay, 360 times 30. I gave away my calculators. 10,800. And that would still be pi. So I simply multiplied both sides by 360. Now, what are we trying to solve for?
X.
X.
So you divide by 169.
So I divide by 169 pi. Now, before you start freaking out, what's going to happen to the pies? They're gone. Yep, they're gone. So X is 10800 over 169.
63.90.
63.90. Choose enough.
Oh, then it's 9-1.
Then it's 9-1. Now, what's the unit on that?
Degrees.
That's degrees. Why is the unit degrees? Because we're looking for the angle. Right?
Yeah.
So, that problem looked different than the ones we did earlier, but it used the same formula. So you're setting it up exactly the same way. A sprinkler irrigates a circle with a radius of 5 meters. So let's draw a picture of this. We got a circle. Here's the sprinkler right here in the center, and it's got a radius of 5. Okay? Find the area that is watered if the central angle is 120. So the central angle is 120. This sprinkler is just switching back like this. It isn't going the full circle. It's just going through 120. So your job is to find the area that is watered. Okay? What do we do? 120 over 360 times 25 pi.
Come on, Lord.
Pi r squared, and it was 5, yeah? So does this reduce? So let's do this one by, we did that one decimally, let's do this one exactly. Does this reduce?
Of course, cancel out the zeros.
The zeros cancel.
And, it's 6 over 6.
1/3 times 25 pi over 1.
25 pi over 3.
So 25 pi over 3 square meters. Which if you wanted a decimal, you could get it, but that is the exact answer. See how that works? So you got a word problem, you're gonna try to draw a picture of it. Because as soon as you draw a picture of it, then it starts looking like the other ones that we did. All right, Lauren?
Are we ever going to try to find the radius, or are they
You could find the radius. I mean, I don't know because we don't have one on here, and I haven't written all the practice tests and stuff. But that wouldn't be a problem. It would just mean you had r squared here. So in the end, you'd have to square root.
okay?
If you were looking for r using that formula. All right, now let's look at some weird shapes. So the next problem, I'm going to try to draw this somewhat similar. Looks like this. And your job is to find the area of that figure. Now, you might think to yourself, oh, Mrs. Ford, come on, who would ever have to do this? Well, those of you who live in homes, houses, and you have yards, most of your yards aren't perfectly rectangular or perfectly triangular. Most of the properties are a little bit off. But your parents have to pay real estate taxes. And part of your taxes are based on the area of the land that you own. So that assessor has to know the size of that lot. So let's say this is your lot, your house is sitting in there somewhere, and we need to know the area of that whole piece of property. All right? Now I gave you a hint by drawing in that line. Because the easiest way to find areas of weird shapes is to divide them up into triangles. Think about yesterday. Remember the hexagon we did? What did we do with the hexagon? Split it up into triangles. What did we do with the pentagon? Split it up into triangles. So when you have any kind of shape, at least think about dividing it up into triangles. All right, so this one's divided up. We got the blue triangle, and we got the red triangle. All right, tell me about the blue triangle. What's its area? Yep, 1/2 base times height. Remember, base and height are the perpendicular sides, right? So the area of the blue is 1/2 5 times 4, or 10. Did I put units on this? Nope. All right, so it's 10 something square feet or something. All right. Now what about the red? Izzy?
I did a squared plus b squared equals c squared to find that line.
Oh, wait a second. Izzy said she can find this line right here. I'll call it X. By doing the Pythagorean Theorem.
And then you know that that's 90.
And since that's a 90 there, wouldn't this be the base and the height? So x squared plus 6, no, x, no, I'm in the wrong triangle. 5 squared plus 4 squared equals x squared. I'm in the blue triangle. So 5 squared plus 4 squared. So let's see, 25 and 16. Square root of 41.
6.40.
Which I can leave exact or get a decimal for, depending on my directions. Let's leave it exact for a moment. Then we'll get a decimal for it. We'll do it both ways. So that's root 41. So tell me about the area of the red triangle. 1/2 root 41 times 6. So that would be 3 root 41 because 1/2 of 6 is 3. One half of 6 is 3, right? So how do I get the area of the whole figure then? Add them together. So the whole shape is 10 plus 3 root 41. Now you can't add those. That is 10 and 3 root 41. They are not like terms. So exactly, this is the answer. Don't do anything else to it. That is it if we're going exact. If we want it decimally, 10 plus 3 times the square root of 41 is
29.21.
29.21. Does that sound right?
Yep.
Now, this is one of the things that makes math so fun. You got to go back and pull in things from the old days to answer your question. So we needed to recognize the Pythagorean Theorem in there, or you could have used the law of cosines. The Pythagorean Theorem's easier, but you could have used the law of cosines.
For the why? Okay, so I'm confused on why we learned the other area. Like, how do you know when you would use which one?
Doesn't matter. You can use either one. So if you take your calculator out, type 1/2 5 times 4 times sine 90. Bingo. So Izzy's question is, how do I know what area formula to use? And my answer to you is, it doesn't matter. Use whatever area formula you want. Now, obviously, you got to have the right information to use it, but you did, Izzy. You had side, and included angle. Absolutely, do it. All right. So, this is going to be tricky. I think we can get it done. Let's see. Get as far with it as we can. All right, so now we've got this random shape. That is definitely a random shape. That is nothing. It's not a kite, it's not a it's not a parallelogram, a trapezoid, it's nothing except a random quadrilateral. So how did we say we were going to approach finding the area of something like this? Sam?
I think like the top of 60 down to the 110.
I think that is a great idea. Sam says he's going to split this up into 2 triangles. We'll call them triangle 1 and triangle 2. And the beautiful thing is, triangle 1, he can already find the area for. Either doing 1/2 side, sine, or doing 1/2 base times height. Either one. You can find the area of triangle 1. And that is 2400 square whatevers. Now that's done. I'm gonna set it aside and I'm gonna focus all my energy on triangle 2. Now we don't know very much about triangle 2. We need to find some more information. Does anyone see any information we could, or we could do the Pythagorean Theorem on the blue line?
Yes.
And that would give us another side of the triangle.
Right.
So 60 squared plus 80 squared equals x squared. This is going to be big. Is it 100?
It's 1,000 or 10,000.
But you gotta square root it.
Yeah, it's
Oh,
So I think it's 100.
it's 100. Yeah.
So we did the Pythagorean Theorem, and now we know that this side of the triangle, I'm talking about triangle 2, this side of the triangle is 100, and that side is 110. You could find the area if you just knew this. Would you agree with me?
Yeah.
Because then we could do 1/2 side, side, sine. Now, some of you might say, well, isn't it just half of 125? No, that's not an angle bisector. No.
Can you just shove it?
What?
Sorry. It's not a right triangle.
Wait, stop. What did you say? You can absolutely do SOHCAHTOA in this triangle to find this angle right here. Because once I know this angle, I can subtract it from 125 and find this one. That is exactly what you want to do. So let me call this angle Y right here inside this little triangle. And I heard you say tangent. The tangent of Y equals 60 over 80.
Yes. Second.
So second tangent, 60 over 80,
36.87.
36.87. Now, are you still with me? This is so exciting. This is this angle. This is the one we needed.
125.
The whole thing was 125. So what's this part of it?
88.13.
88.13?
And now we can find.
Now we can find the area of triangle 2 because it's 1/2 side times side. Oops, other side's 110. Times the sine of the included angle, which is 88.13 degrees. Wow, that is a massive problem. Your minds are blown, but you should be so proud of yourselves. We got it. What is that? 1/2, 100, 110, sine 88.13 is?
Where do you get the 100?
That's a lot.
5,000.
This side times this side times the sine of the included angle. What is it?
5,000. Wait, what? I got 5,497.07.
0.07? Anybody match that?
Me.
Now, we're so excited, oh my gosh, but we don't have the answer yet. Because our job was to find the area of the whole shape. So now we have to take the one we just got and add the 2400 to it. Because the shape is triangle 1 and triangle 2. So,
7,897.07.
and there it is. And that would be like square feet or something, depending on whatever unit we had on there. So, couple of things. I know that's a lot. But a couple of things to always keep in mind. First of all, the notion of splitting it into triangles. That's good. Split it into triangles. Second, sometimes you can't actually find what you need in the triangle you have. You got to find it in the other triangle and then subtract or add or something to get what you need. You see what I'm saying? I couldn't find that angle. I had to find this one and then subtract it from 125. All right, do we feel smart or what? We should feel very smart.